We define power as the work done or the energy converted per unit time. We can do the reverse and write energy or work equals power times time. Consider an electrical appliance that uses a kilowatt, say a toaster or a hairdryer. Good question. What would I know about hairdryers? The appliance runs for an hour. How much electrical energy does it convert? Well, we multiply 1,000 watts by 3,600 seconds. This gives us 3.6 megajoules, which is known as a kilowatt hour. A kilowatt hour, power times time, gives energy. The kilowatt hour is a unit of energy that the electricity companies often use. Depending on where you live and the time of day, they will sell a kilowatt hour of energy for between, very roughly, 10 cents and $1. If this looks like a bargain, that's because it is. Let's put it in context. A unit for power used in the USA is the horsepower, which is 746 watts. This may not seem much for a horse, given that I was producing 700 watts here. The difference is that a horse can provide this power all day. For a human, over a whole day, even 100 watts is a pretty large value. Long before electricity, only rich people had horses. Most hard labour was done by humans. So let's imagine that I'm a labourer. Tote that barge, shift that bale, and that I produce 100 watts. I work a 10-hour day. Back then there were no unions. So I produce 1 kilowatt hour in a day, and I collapse at the end, exhausted. So let's have a look at an electricity bill and replace kilowatt hours with labourer days. Viewed that way, it's a bargain. As to why energy is so cheap, that's a difficult political question. Well, now that we can analyse and quantify forces, work, energy and power, there are many important practical questions that we can investigate. We'll do some of those in the quiz and in the test, but I'm hoping your curiosity will drive you to look at a lot more. Next week, momentum, collisions, and yet another way of presenting Newton's second law. We'll also have some fun. See you then.